Thanks everybody for coming out. We're here to talk about what's new in OpenSearch and the OpenSearch service. I'm Carl Meadows, Director of Product here at AWS. With me, I have Mukul, who will be coming up, Mukul Karnik, who's our director, and Corey from NVIDIA. Nolette is going to talk to us about how they've helped us with OpenSearch as well. So before we jump in, it's important to talk about, like, hey, what do I do with this OpenSearch thing? So OpenSearch is a very popular platform for a number of use cases. First and foremost, as the name implies, it's a search engine. And so it is super popular for building search applications, and more search applications are becoming the foundation for Gen AI and AI-powered applications that leverage OpenSearch as a search backend. Additionally, it's very popular with analytics use cases where, since it's a very flexible engine, the data is highly indexed and is fast, and you can find the needle in the haystack. It's very popular for observability, security analytics, and general real-time analytical use cases where I can on the fly do aggregations, do searching, and get deep insights into my data. When we talk about OpenSearch, there's a set of open source technologies that power OpenSearch, and then there are the AWS services that we provide for those open source projects. So the primary open source pieces when we talk are Data Prepper, which is an ingestion pipeline that sits in front of OpenSearch that we deliver as OpenSearch ingestion service. Then there's OpenSearch itself, which is the engine, the core data engine analysis engine, which is delivered via Amazon OpenSearch service and our serverless offering. And then the front end for data visualization and exploration is powered by OpenSearch dashboards. In the service, we deliver this as OpenSearch UI, which is a centralized dashboard that you can use to connect to any of your OpenSearch service or collections, which we'll talk about. So before we jump into the service, I want to talk a little about the open source. So OpenSearch is an open source project. Last year, we transitioned it to AWS being the primary steward, to transitioning it to the Linux Foundation. And it's been a really great year. We launched the OpenSearch Software Foundation to support the project in the Linux Foundation. We're a premier member. Recently, IBM joined us as a premier member. We have a number of other community members also helping us support this project. The folks supporting the project are actually independent from the people contributing to the project and the actual maintainers of the project. Anyone can participate in the technical merit drives the governance of the project, but these folks are the ones that are helping us put together events, do trainings, really spread the word about OpenSearch to help make sure that we've got a broad, thriving community. And in the last year, I've been really thrilled with the progress that we've had with OpenSearch. So since the initial fork, we're now up to 1.3 billion downloads, which is a lot in 4 years. We've got, in the last year, we've had over 3,000 active contributions from 400 different organizations. It's not just the number of contributions, it's the deep, meaningful contributions that we're starting to get into the project that's really driving a lot of excitement and momentum around the project. As evidenced, user communities have spread up across the globe. So if you're in any of these dots, you can look up and find the user community, and you can go to local events and participate with the other folks that are interested in OpenSearch. If there's not a dot there, talk to us. We can help you set up a user conference. It's really exciting to see this community growing. And when you think about so why are people gravitating to OpenSearch? Well, choosing a platform that's going to be as important to your business as your core search engine and your core analytics engine, these are multi-year bets. You're making a large investment. And so it's really important that you feel like that's innovating, that's sustainable. And it's really, I think, that innovation as you can see by the progressive, more and more meaningful features we've been able to land in OpenSearch every year, I think that gives people confidence that like, hey, this is the horse I want to bet on. This is the project I want to be involved in because look at all this innovation I'm getting for free by participating in this open source project. So just, really excited about, where OpenSearch is headed and all the things we're doing there. And another reason is, since we've started the fork, we've taken a deep look into the engine on how we can really improve performance. No data engine ever went wrong by being, cheaper, faster, or more resilient. And so we've, since the 1.x line, which was essentially when we started the fork, to 3.3, which is the most current release on the service. Actually, most current release, 3.4 doesn't release for another couple weeks. So most current release, we've had 11x improvement in overall search and aggregations, and a 2.5 increase in our vector search functionality. And we're not done yet. So we're going to continue to drive greater efficiency, better performance, and lower costs on the engine as we increase, which we'll talk more about as we go. So really excited what's going on upstream. And then here at AWS, we take that project and we deliver it to you as Amazon OpenSearch Service, which maybe a little biased, but I think is absolutely the best way to consume the open source project, because we wrap the service up, provide you, operational simplicity, all of the features and benefits you get in the open source with none of the pain of managing it, cost efficiency, and it's deeply integrated into the AWS ecosystem, which makes it super easy for you to integrate into the rest of your AWS operations. And as evidenced, over 100,000 active customers use the service today. We process more than 10 trillion requests per month on the service. It gives you a self-managed patching, one-click upgrades, 24/7 monitoring, self-healing, no downtime. You can completely change your topology from with a click of a button, and no downtime. We'll do a blue-green and move you to a completely new environment. Provides deep security features like fine-grained access control, encryption keys, audit logging, all the things that you need to run an enterprise-grade application. We support multi-AZ deployments, SLA up to 4 nines on a single cluster. And we built a lot of innovation into the product as well on top of the open source for delivering great economics, such as our ultra warm features, specialized instance types like the OpenSearch instance, which we'll talk about, that give you a full resilient environment. Yeah, so it definitely, if you're running OpenSearch, I believe we're the place to do it. So as we jump in, when you think about the landscape, most simplistically, you've got a bunch of data. That could be in the form of documents, logs, in a transactional system. It could be embeddings. It could be pictures and videos and other things we could put on here now too. I want to take that data, process it, and then eventually land on OpenSearch Service, and then vend out the use cases that I'm from OpenSearch Service to my end customers. So when we talk about that first part, the data ingestion part, I mentioned Data Prepper and the OpenSearch ingestion service. And what this is a very simple serverless capability that allows you to have, select a source. It provides a buffer and processing and transformation on that data, and then we'll sync that data into OpenSearch, into a managed cluster or a serverless collection, and also can sync data into S3 as well if you want to do routing such that, like, hey, I want all my raw data in S3, I just want to put aggregations into OpenSearch or things like that. You can do that in OpenSearch ingestion very easily. Oops, wrong button. There we go. So some of the things we've done in the last year with OpenSearch ingestion, we increased I mentioned it's a serverless product, so it's powered by OpenSearch compute units. You don't have to provision anything. These automatically provision for you and scale up and down based off of the traffic that they're processing. Well, we increased the memory of those at no additional cost to 15 gigs so that even the largest aggregations or complex computing jobs we could do on those pipelines without having to scale out additional pipelines. We also enhanced the auto scaling so that it's getting more signals to be more responsive to different types of changes in demand. And when you look across the capabilities of the OpenSearch ingestion, you'll see there's a wide range of sources that we support. It supports both push and pull sources, so you can push to it through like an HTTP endpoint or an OTel endpoint, but it can also pull from systems like Dynamo, DocDB, RDS Aurora, RDS Postgres, Elasticsearch itself, OpenSearch itself. And one of the most popular is actually pull data out of S3 and process it in OpenSearch. We've added, I mentioned RDS and Aurora, we added Jira and Confluent, and we're going to keep adding connectors, just make it really easy to get data into OpenSearch. Then once it's in the pipe, you can do a large amount of processing on that data to enrich, select entries, do conditional routing, drop, aggregate, do OTel processing. We added this year a Lambda processor, which there you can call out, and anything you can write in a Lambda, you could then do on that data stream. So if none of these processors work, or you want to do something different, you leverage that Lambda to say, maybe enrich that data from another data source outside the service. You could write a custom connector. We also added batch AI inference to make it really cost-effective to build embeddings off this pipeline. And then, like I said, you would sync that data into a managed cluster or serverless collection or into S3. Another feature that I think is really improved the usability we launched this year is an improved UI or user experience that gives you a guided visual workflow. Turns out that not everybody just wants to write YAML, so making this easier to write these processors so that you can have high confidence that the permissions are set up right, the processors are configured properly, and a few clicks, and that the data is going to be delivered in the format that you want while building these pipelines. All right, and so with that, I'm going to turn it over to Mukul, who is going to walk us through logs.
Yep. Thanks, Carl. Folks can hear me, right? Yep, cool. So one of the impressive things in Carl's talk was just the sheer momentum we are seeing in OpenSearch. So getting to 1.3 billion downloads in 4 years is an achievement. So the project is really growing fast, and we're seeing, just the momentum even grow faster. So really excited to see that. Before I get into logs and after that search, I wanted to just get a sense of how many folks have used OpenSearch for logs use cases. Okay, so a few out there. And how about search vectors? Okay, so kind of more on the search vector side. Good to see that. So yeah, so as we know, log data continues to increase, and with GenAI and agents, it's even increasing even more. So why do we collect all this data? We collect all this data because downtime happens in software, and when there is downtime, you want to reduce the MTTR, or the mean time to response, and come back online. And to do that, you need to debug and get to the root cause quickly. And that's why you need all of the telemetry to get to that root cause. I think Gartner did a survey a couple of years back. They found that on an average, a company has 87 hours of downtime and spends about 3.6 million in lost revenue or sales. And so it's really important to reduce that downtime and get to the root cause quickly. And to do that, you typically need a single pane of glass. The log data can be in different places. Some data can be in CloudWatch. Some of the data is in OpenSearch. Some of the data can be in S3 because it's just too expensive to index it. And what we launched last year is OpenSearch UI, which takes the OpenSearch dashboards, open source project, and is a fully managed SaaS experience that now connects to not only just OpenSearch, so you can connect to multiple OpenSearch clusters, But you can also connect to data in CloudWatch, you can connect to data in S3, in Security Lake, and have the singular view from this one endpoint where you can kind of visualize the data in a single dashboard. So really powerful to be able to do that because data exists in different places and it's expensive to kind of bring it into one place. So this is kind of a set of new things that we've launched, like the CloudWatch integration and the Security Lake integration. We've also been improving the experience of the OpenSearch dashboards UI. So how many folks here are familiar with the Discover experience? Not many, I guess. But we've been really improving this experience. And the key area where we've improved is be able to type in a query, which is a PPL query, and I'll jump into what that PPL is, and get visualizations as well as logs. So you can get the raw data, which is the logs, or you can get aggregations and visualizations, and you can kind of get trends within your logs pretty quickly with this kind of interface. And the key power here is the PPL queries that we've implemented. So PPL is a pipe programming language. It supports different kinds of commands, search, dedupe, and all kinds of commands to basically extract, filter, and transform log data. And so with this, you're able to deep dive into logs and get kind of the insight that you're looking for. And over the last year, we have spent a lot of, we focused a lot on improving the PPL capabilities, adding a lot of new analytical capabilities to PPL. So we have added ability to join indices. So if you have log data in 2 different indices, you can now join them using PPL. You can do additional kind of lookups and filters, and so it's a pretty powerful set of capabilities. Just this year, we've launched about 39 different capabilities, and in the OpenSearch 3.3 version that was released last week, you'll find that all of these capabilities are available, and would be really good time to try this out. And I'm going to jump into a demo of how the new dashboard experience, along with Discover and like these PPL capabilities, can help you get to what you're looking for in your logs. So here's the new OpenSearch dashboards experience. We launched this like late last year, and since then we've been improving on it. You have this concept of workspaces. Think of workspaces as a unit of collaboration. So if you have a team that you want to have collaborate on, say, on observability use case, then you can create an observability workspace. We have other workspaces like security analytics and search workspaces. But let's click into an observability workspace and see how things have changed. So when you click on it, you land on a newly designed Discover experience, where at the top you have a place where you can enter the PPL commands, and then you can quickly look at the logs and visualize the trends of the data in those logs. So that's kind of at a high level how it works. Now let's say you have an issue going on, right? Then you can quickly type in a PPL query where you're searching for error in your logs. That's effectively what you're doing. You type in that query, and then you are able to visualize, okay, here are some of the errors in my logs. And then you can click on the AI summary and understand actually LLM summarized view of what is going on in your logs. As you read through that, you quickly realize that the errors in your logs are actually nested into a body message. And so it's becoming kind of hard for you to debug what's going on, and you want to maybe extract the error message from the body. So you can now go and update your PPL command to extract fields from your JSON object that is there in your logs. And with that updated command, now you're able to better pinpoint all the errors in your log. So initially, it looked like there were many different log messages, but it boils down to this target error message that is coming. And so now you want to figure out, okay, looks like there's an error that's happening. Is it a big problem or not? Like, so you want to be able to do stats on it, and so you can quickly do stats and find out, okay, like how often is this happening? And looks like it's happened, 70,000 times, so it's a significant issue, and you kind of probably want to know what's going on. So now what do? You want to ideally find out, which service is kind of causing this issue, and how can you get to, the owner of this service. So you can join this logs data with maybe, service metadata that you have, and with that, you're able to find out, okay, these actually error messages are coming from the load generator service, so maybe it's not as critical as, a production system, but still, you can get to quickly, okay, find out what's causing these errors. And then you're able to kind of take those error messages and find out, okay, when did they start? And so you can have a time span and find out, these error messages started at a particular time, and you can use that to engage the owner of the service and get kind of it resolved. You can also take the visualizations that you've generated here and add them to your dashboard. So that way, the next time you go, you can just directly go to your dashboard and look at the errors. So it's a pretty powerful way to get to root cause of the errors that are happening in the system, debug it using PPL. Now you may not know PPL, like many users are not familiar with PPL, so we also support natural language, which is pretty intuitive, where you can just type in, a natural language query, and it generates the PPL and, of course, gives you back the response. One of the things that we've also been doing is adding MCP capabilities, and I'll talk about it a little bit later, to OpenSearch. So if you have a OpenSearch backend, and let's say you have an agent that you built that's looking through all your logs in different systems, you can use the MCP server of OpenSearch and pass in these natural language questions or the PPL questions, and the rich analytical capabilities, all the functions, the joins, all of that are available through that MCP integration. And so you are able to get, again, to that root cause pretty quickly without having to even maybe interact with OpenSearch dashboard. So pretty powerful kind of core capabilities that y'all can leverage for debugging logs. So that's kind of the logs overview. A lot of improvements and many coming over the next year as well. So if you have not looked at OpenSearch for logs, you should definitely look at it. Now search and AI. A lot of there's a lot of innovation going on in Gen AI, a lot of excitement, a lot of new models coming out, and search is changing. And in this world of Gen AI, if you think about it, at the core, like this problem of search is core problem of information retrieval. And like you have, different kinds of information. You have, documents, you have images, you have videos. Like you want to, the goal of search is to really be able to extract that information so that you can get to your insights quickly. And to do that, there are several techniques, right? And if you looked at about 20 years back, keyword search was a big thing, and typing in the keywords and finding relevant information was really useful. And then as machine learning models came along, you're able to do semantic search, and with that, you're able to find not only the exact keywords, but like similar sentences that had semantically similar meaning. So it was very helpful to kind of get semantically relevant information from your data. Then came what we realized is actually keyword works really well for 70 to 80% of the use cases. So combining keyword search along with semantic search and developing hybrid search was the next kind of innovation that happened in search. And these days, we see actually hybrid deployments, hybrid search deployments across many customers. Many customers are using hybrid search for all kinds of use cases, whether they're searching for data in their internal systems, whether they're powering their external-facing user applications. So a lot of use of hybrid search across different systems. We also see customers using OpenSearch for new use cases, including agentic search, where they want to not only leverage that data that's available in OpenSearch, but also leverage data in other systems outside OpenSearch. And so we'll go into details of all of this, but that's how search is evolving, and a lot of innovation happening in a very short time frame. So let's look at a typical search workflow these days, right? You have your data or information, images, documents. You take this and you typically index that into OpenSearch. You also use a machine learning model to generate vector embeddings, and you store those vector embeddings in OpenSearch. So you'll have a lexical index, you'll have a vector index, and you store that information in OpenSearch. Then when you get a query, you're able to kind of use both these indices to retrieve the relevant documents and then do re-ranking if necessary and surface those documents or the results to your user. So that's a typical kind of search workflow that we see. The challenge is, it is pretty complicated, right? You have to figure out which model to use, how to host the model. Then you have to generate all these embeddings, store them in a separate index along with the lexical index, and then figure out how to combine these results in an intuitive way. So it's a pretty complicated setup. So one of the things we launched pretty recently was automatic semantic enrichment. Think of it as an out-of-the-box semantic search and hybrid search capability for your use case. In this case, you are simply sending your documents to OpenSearch. In the background, we are using a sparse neural model that we host and manage, and we generate the vector embeddings and the semantically enriched documents that we store along with your data. And so you don't have to worry about hosting. You don't have to worry about paying for the GPUs when you're not indexing. So it's pay as you go, but it kind of enriches your document. And then when you're querying, you are able to leverage the semantically enriched index and get better search results. What we've seen in our testing, and we've used different benchmarks, is that this technique actually does really well compared to even like the other embedding models that are out there. And so it's a really easy way to get started with semantic search and hybrid search for your application. So if you're not using any of these techniques, this is a very simple way to get started. Let's kind of dive deep and understand how this semantic enrichment works. So let's say you have a text document. In this case, we have picked, the Cricket World Cup, which happened last year, and it got a bunch of documents related to that. And during ingestion, when you ingest those documents, we call a machine learning model to expand the vocabulary and generate semantically similar words to what is there in the document, and store that along with your regular data and index. And when the query comes, we are able to leverage this semantically enhanced, think of it as synonym dictionary, to be able to give really relevant results for use cases. So it's a pretty powerful technique and a pretty simple way to improve the accuracy of your search results. So let's talk about OpenSearch as a vector engine, right? Like all these machine learning models generate vector embeddings, and you want to store these vector embeddings in some place. And OpenSearch is a pretty popular vector database these days. The reason is we started building vector capabilities in OpenSearch in 2019. And at that time, there were very few machine learning use cases for things like personalization, for similarity search, and so we needed maybe 10 million vectors was sufficient. And so OpenSearch kind of started with that, and as years progressed in 21, 22, that grew to 1 billion vectors, and we are supporting more of the BERT kind of models that were out there, still a reasonably small size. Then in 2023, 24, as Gen AI became really popular, we started seeing a lot of use cases for larger workloads, and OpenSearch was now supporting up to 100 billion vectors, like Amazon's fraud detection system uses OpenSearch for up to 70 billion vectors. And so it's a pretty large use case where OpenSearch scales really well. And more recently, like many customers we see are wanting to index and create vector embeddings for all their documents. And that makes sense because all these models are pretty powerful, and you want to get most out of your data. And to do that, you want to generate these vector embeddings. And now we support up to 1 trillion scale on OpenSearch, which is really useful for the large use cases for using vector embeddings. But doing that at that kind of scale can be expensive, right? And so you got to be able to do it in a cost-effective manner and quickly. To do it cost-effectively, of course, if you put all of your data in memory and use exact KNN search, you're going to get the best results, but it's the most expensive. The next thing you can do is use an approximate technique, keep the data still in memory, and that approximate techniques will help you, reduce the amount of data and amount of compute you want to use, and kind of reduce cost. Then we introduced the disk mode again early this year that lets you keep the vector data on disk and only kind of quantize data in memory, and that reduces cost even further. And just yesterday, we announced the general availability of S3 vectors and the OpenSearch integration with S3 vectors. And with that, you can keep your data all in S3, the vector data, and reduce your cost even more. So as we get to this trillion scale, there's different ways to reduce cost and get to that scale. So let's look at the disk optimized vector mode, right? The way this works is you take the high dimensional vectors that you have and you use different byte quantization techniques to generate vectors of lower fidelity. So you get up to 16 or 32x compression, and you keep those vectors in memory, and you keep the high precision vectors on disk. And then when you get a query, you first do a KNN search or a approximate search in memory for the byte quantized vectors, get maybe 1,000 results instead of the 10 results. And for those 1,000 results, you kind of retrieve the exact, the high precision vectors and do an exact KNN. So with that, it's a 2-pass kind of method, but you still get the high recall and that you're looking for, and you don't have to keep all of your data in memory. The only thing kind of caveat is that it adds a little bit more latency. So if your workload can tolerate a little higher latency, this works out pretty well. The other kind of way to do this is to use S3 vectors, which we just announced. And there's two kind of integrations we have with S3 vectors. One is you provision a cluster, and you can now pick S3 engine as a vector engine in OpenSearch. Once you pick S3, we will, when you send us the vector embeddings, we'll store them in S3 instead of storing them in OpenSearch. You can still keep the lexical index in OpenSearch. That way you have the vector embeddings in S3, the lexical index in OpenSearch, and when you get a query, you're able to do the vector search using S3, you're doing the regular search using OpenSearch, and you can kind of combine those results and still do hybrid search and get all of the rich OpenSearch functionality while getting the kind of low cost of S3 vectors. This works really well for use cases where you don't have high TPS. Like at higher TPS, you may want to keep all of your vector data in S3 as well, in OpenSearch as well. But for a low to mid kind of QPS use cases, the S3 vectors will give you an improvement in cost. So that's one way to use S3 vectors. If you want to, the other way to use S3 vectors is to keep, take the data in S3 and bring that into OpenSearch. So you could choose to, for example, bring only the latest data, or like, data for a particular category or a segment into OpenSearch, and use that for vector search. That way you're not bringing in all of this information into OpenSearch, and that's another way to kind of use OpenSearch in combination with S3 Vector. So these are the two kind of integrations we have available. With that, I want to bring Corey on. He's going to talk about how NVIDIA has helped OpenSearch scale to this trillion vectors.
Awesome. Thank you, Mukul. Hey, everybody. Can you raise your hand if you can hear me? Just a quick sound check. Awesome. Nice. Kept these seats full. Yeah, I'm Corey Nolet. I'm a principal architect for vector search, various machine learning libraries at NVIDIA. This is no surprise that vectors are the language of AI today, right? Unstructured data. As Mukul pointed out, trillion vector scale is becoming more commonplace. Even just as recently as 6 months ago, I would hear trillion scale thrown around by maybe 2 or 3 different organizations, and I'd hear it maybe once every 3 or 4 months. Now I'm hearing it literally weekly. People are really paying close attention to this. A lot of organizations are in the process of kind of dipping their toe in the water, and we're really seeing this trending up. If we can get to 100 billion scale, we can get to trillion scale, right? If we can get to 10 billion scale, we can get to 100 billion scale. So growth has been exponential, we've been seeing, since about 2017. What a lot of people don't realize, and Mukul kind of alluded to this as well, is that vector search indexes are not like traditional database indexes, right? They're approximate, and when you make something approximate, that now means that you have to model it, right? Which now means that it's a machine learning model, right, of some sort. So, traditional database indexes, if we don't tune them properly, right, we still get the correct results. We just may not get them back quite as fast, right? Vector search models, we have to consider the trade-offs, right? For a more accurate model, we may not necessarily get the best indexing throughput, right? We may not necessarily get the best search throughput. And we have to make these trade-offs. Well, these trade-offs can be fairly expensive. They can have a huge impact on both cost and performance. That's the big deal here, right? And so by utilizing GPUs, we can try to work with some of those trade-offs and make them more manageable. We can make them more cost efficient. We can make them higher performance, right? Especially at trillion scale. And so our partnership with AWS OpenSearch team kind of formed around these 4 challenges that we're finding, right? And I'm going to walk through in the next 8 minutes or so how we constructed our solution to address these 4 challenges. The first challenge being index builds, right? Indexing a trillion vectors, building machine learning models for a trillion vectors can take a long time, as you can imagine, right? It doesn't necessarily scale linearly in all cases, right? Interoperability is a big deal too. Something a lot of folks don't realize is in agentic AI and RAG workloads, most of the time, at least at the present moment with our current technology, the actual vector search lookup is not often the bottleneck, right? When you have an LLM in the mix and you might be reaching out to a different remote service to inference with that LLM, or even if the LLM is local and it takes several hundred milliseconds, that's usually orders of magnitude longer than the vector search. If I could do the vector search in 0 time, I'm gaining nothing, right? So having a GPU to do that allocated for that period of time and sitting idle for most of the time doesn't make sense, right? So it's important that we're able to interop, that we can build indexes really, really fast on the GPU and not lock you into GPU for search. As Mukul also pointed out, mixed types are a big deal, right? We're not often just doing a semantic search. We might need to do a structured search, combine that with a semantic search to improve our results, or even just to make our results, right? We might need to query from geo coordinates within a certain bounding box and do a filter by a certain age group before we do our semantic search. And then, of course, last being cost efficiency. We don't want to have to spend a lot more money to be able to do this on the GPU, right? We want to be able to really have a mix of both. So we've been working for the past couple years with our AWS OpenSearch team to solve these 4 challenges. So I'm going to put the solution together into a little layered stack like this. I'm going to start with the index build, which you probably recognize as green to signify NVIDIA. So it probably means that it's being done on the GPU. A couple years ago, we created a library called cuVS using our standard cu prefix for CUDA vector search. Why? another library. Well, CUDA can be challenging to write. It can be expensive to write because it's challenging. It can be very low level. You can spend a lot of time optimizing an algorithm in CUDA, and then a new architecture comes out that introduces several new instructions. A new library comes out with a nice abstraction. Now you've got to rewrite or refactor your code. So you're constantly playing this catch-up game. And so one of the big benefits of having a library that you can just pull off the shelf that can provide the building blocks for implementing vector search, whether that's directly in an application or inside of a database, is you allow us then, the manufacturers of the GPU, the creators of the CUDA versions, to maintain this going forward, making sure that you're always getting the best performance, the best cost efficiency out of the hardware and the software. And so it's fully open source. It's Apache 2 licensed. The goal is to provide both the building blocks and end-to-end algorithms. So again, can be used in applications, but also integrated into databases. We build on top of all the foundational libraries that you would probably be used to if you were doing CUDA development. Right, so most of the algorithms that folks are using today, especially off the shelf in a lot of the databases, we're working to change this, right? But most of the algorithms that you're using today are on CPU. One of the standard algorithms being the HNSW algorithm, graph-based algorithm, really fast search, not so fast build. HNSW is not foundationally a really GPU-centric algorithm, right? It utilizes multiple threads, locking on a centralized data structure to try to have low latency for insertions into a graph. So we kind of had to go back to the drawing board, and we built an algorithm that we call Kagra from the ground up for the GPU to be able to do the construction of this graph in one big batch, minimal to no locking. You know, Kagra's proving to be a pretty useful algorithm. It's a little bit different fundamentally, right? The H in HNSW stands for hierarchical. Kagra is not hierarchical. It's a flat graph, right? The SW stand for small world. Kagra is not a small world graph, right? But it turns out that it is navigable enough that we can convert that into a HNSW graph. Now, we find that as the number of dimensions increase, like today's embedding models are getting kind of out of control, right, with the number of dimensions that we have to use. We can compress them down. We can kind of make it a little bit better. They're still kind of out of control, though. So we notice that the gap increases when we're building indexes as the dimensionality increases, as the scale increases, the more vectors that we need to index, but also as the quality of the model increases, right? So as I want a model that can give me 99% recall versus something that gives me like 80 or 85%, then we're going to notice that gap increasing even more. So unsurprisingly, the lowest rung on our stack diagram here would be the cuVS library that we've provided to solve the challenge of index builds. So for the challenge of interoperability now, we can convert this Kagra graph into an HNSW Kagra graph so we can search, into an HNSW graph on the CPU so that we can search on the CPU without losing any quality, without losing any latency, right? This bottom chart here can show you can actually benefit in some ways on getting better latency by doing this conversion. But this is a big deal. So we can build indexes 20x faster or more on the GPU, and then we can convert them so you're not really losing anything, right? And that still provides a little bit of a challenge, right? The phase library here has, for several years now, they've kind of pioneered vector search on the GPU. Before we called it vector search, it was approximate nearest neighbors, and this was an approximate nearest neighbors library that came out of Meta. They've done this stuff for a long time. They've done a great job at it. Their algorithms are really well optimized for both CPU. They also have GPU algorithms. We have been collaborating with the phase folks for about the past 3 or 4 years. We will eventually swap the phase classical GPU backend out for the cuVS backend. We're kind of working towards that. But at the present time, we have a backend for cuVS for phase, and this provides that seamless interoperability. So you can build an index on the GPU, then you can search the index on the CPU. This is another one of those missing pieces here, this operability piece, right, that we can put on our rung right here. So the phase library kind of became our solution to that. And it was kind of delightful to find out that AWS OpenSearch had already invested in a phase backend for OpenSearch. So they were able to reap the benefits of that interoperability, mostly by flipping a switch to now use the cuVS backend on GPU for building indexes. And so mixed workloads is a big deal, right? It's not enough to say that I can do a semantic search now. I have to have a solution that's going to let me do that hybrid in between, doing the structured, doing the semantic, doing the sparse lexical search along with the semantic search. So the Amazon OpenSearch service has enabled this. They have pulled out the standard, let me build the index and then let me search the index in the same process. They've pulled this out into separate processes now. So we can offload index building to a different instance if we need to. And that's really a big deal, right? It's not good to have a GPU that I have to pay for all the time if it's going to sit idle most of the time, right? There are many reasons why I might need to build and rebuild an index, especially in the foundational architecture here, which is Lucene, right? I might want to adopt a new model. Well, now I need to rebuild my indexes. I might want to do some level of tuning of the parameters so I can find the recall and latency trade-off that I need. Well, that means I need to build new models, right? I need to re-index. So for the mixed types, we've adopted the OpenSearch service. And now this is kind of the big cinematic climax here, right? In order for me to be able to extract a cost benefit out of this, I need to be able to give the GPU back when I'm done, right? I'm not building indexes constantly. I might be building indexes constantly, and at that point, that's great. I can have my index service running. Most people are not building indexes constantly. They might have a continuous ingest going at a fairly low volume, right? But the ability to give that hardware back when I'm done is what really makes this cost efficient. And this is a big deal, right? This is something that our OpenSearch friends, our collaboration with the OpenSearch service developers has done completely novel. This hasn't been done up till this point. And we're finding an extreme benefit here. So some benchmarks here showing cost and speed over on the right, so we can end-to-end, right? If I'm just building the index, I can get a 20x speed up, right? And that's not including having to ship the data to a serverless infrastructure, having to ship the model back afterwards, right? Everything said and done end-to-end, I still see 12x speed up. Sorry, I'm seeing 14x speed up. I'm seeing 12x cost benefits out of this. This is a big deal. So kind of putting this all together, right? I can get faster index builds with the QVS library on the GPU. I can build on the GPU, and I can search on the CPU with the phase library. Putting this all into the OpenSearch service allows me to do this with mixed types with an end-to-end database. And then having the new OpenSearch serverless GPU allows me to give back the GPU computing when I'm done so I can reap the benefits, not have to pay for it running all the time. And so summarizing this again, the 4 challenges that we've solved here. What we're noticing with cost efficiency too, I think was just announced at Matt Garman's keynote, was that we're seeing up to 10x faster. That's an average here at about 3/4 lower cost. So thank you, everybody.
Thanks, Corey. Really exciting to partner with NVIDIA on this. We are seeing some amazing outcomes. Like one metric now is that we can build a billion scale vector index in under an hour. So previously it would take, maybe even sometimes days to build. Now we can build it under an hour. So really exciting to see that. Let's continue on some of the search innovations. So as you all probably know, building a vector index can be complicated. Corey talked about the trade-offs between latency and recall, and then you want to also factor in cost. You have all these different parameters, different modes to configure, and so it can become challenging. And usually you have to, build it, evaluate, and then again, okay, this is not working, so you go back to the drawing board, and it's this kind of rinse and repeat of different parameters, and that can take time. And typically what you're looking for is a trade-off between latency and recall, and cost is a factor as well. So, and the challenge is these parameters behave differently on your data. So if your workload and your data has certain characteristics, it will behave differently than other workloads. So you cannot even generalize it. And so you really need to use your data to figure out what parameters work well to give you the recall that you're looking for and the latency profile that you're looking for. To kind of address some of these challenges, what we launched yesterday is Auto Optimize. So Auto Optimize is a workflow where you upload your data. We take that data and then run through a bunch of different like experiments to find out which combination of latency and recall that you've specified, what is the lowest cost option for that. So, if you're okay with higher latency, we'll recommend a disk optimized mode. If you want really high recall, we'll recommend some particular hyperparameter configuration. So we'll run all the different configurations, and this job will provide you an output that you can directly apply to your cluster and get the best outcome that you're looking for your vector tuning without having to spend days trying to figure out what to do. So this will really help accelerate your POC to production for vector use cases. And as I was saying, we parallelize all the different combinations that you want to evaluate. With the GPU acceleration capabilities, we are able to really do that quickly and give you an output within an hour. So that's kind of pretty important launch. Looking back at the overall OpenSearch stack, the stack has come a long way from traditional search. At the bottom of the stack, you have FIS, you have Lucene, different ways to different engines for OpenSearch, and now S3 Vectors as a new engine. Then you have different use cases, right? You have all the search use cases, hybrid search, multimodal search, semantic search. And then, of course, you have the vector database capabilities of OpenSearch. And you can do, exact KNN, approximate KNN, there's tiered storage in there. And then we are also building many of the AI-powered use cases. So Agentic capabilities in OpenSearch, MCP server, and I'll talk about some of that. And we are also building tools to be able to do, like improve your experience. So being able to have, connectors that connect out to different services, AI workbench where you can, build different workflows. So a lot of this is now part of OpenSearch. So you all should try out for your next application. And like OpenSearch has come a long way from just a traditional search engine. One of the areas we are seeing a lot of interesting innovation is in the agent world. So search is playing a pretty critical role as you all build agents. What we are seeing is agents need context, and agents are very iterative. Like you ask a question, and they are pretty iterative in how they kind of decide what plan to use and execute. And the agentic search is very different from a RAG kind of use case. A traditional RAG use case is you have a query, you go to a vector database, get additional context, and you take that context and pass it to an LLM, right? But with agentic search, what you're able to do is given a query, you take that query, you do some amount of reasoning, you use different MCP tools to get additional context. Then you use some data from short-term memory, long-term memory to get more context, maybe call an LLM, get a plan back, refine that plan based on the additional context. And so it's an agentic loop that you have to kind of execute. And this requires a lot more tools than what we have. So I'm excited to announce that we have many of these tools available. So we have an MCP server, we have agentic memory capabilities, and we also have some specialized agents that we built in OpenSearch. The MCP server is pretty standard. I think almost everyone probably knows how an MCP server works. But OpenSearch has a MCP server capability that you all can use. We have different set of tools like list index, search index that you can directly call using the MCP protocol. And your agents can directly access your data in OpenSearch. And we integrate, we provide authentication and integrate with popular frameworks out there. We also launched agentic memory capabilities in OpenSearch. So let's say you're using OpenSearch for vector capabilities, and you want to store either a short-term or long-term context for your agents. You can now do that with OpenSearch, and you are able to search through that memory using the OpenSearch's search capability. So it's a pretty powerful way to store both the short-term as well as long-term memory. And we have different ways to manage the temporal capabilities. So if you are time-sensitive data, like you can delete that. So it helps you kind of manage that as well. And finally, we have also launched 3 different agents. We've launched the flow agent with OpenSearch, which gives you a sequential kind of execution capability. So if you have like a single turn workflow for search, you can use the flow agent. You can use a conversational agent for more of a multi-turn capability. And so the LLM in this case reasons about which tools to use and gives you kind of that ability. And we've also launched a plan, execute, and reflect agent that leverages the LLM to plan a kind of execution flow, get additional context, and do the deep research work that some agents do. So you can build a deep research agent using that kind of capability. So some pretty powerful capabilities in the latest version of OpenSearch for building agentic search capabilities. With that, Carl can talk about the infrastructure enhancements.
Thank you, Mukul. You guys can still hear me? All right. So we've talked a lot about the capabilities in OpenSearch. Before we close, I'm going to talk a little bit more about the benefits of these on the service. So mention the benefit of Amazon OpenSearch service, the scale, these trillion vector indexes. We do support up to 1,000 nodes in a single cluster, up to 25 petabytes in a single cluster, with high availability, 4 nines SLA on a single cluster, durability of 11 nines when you use OpenSearch optimized instances, which are S3 backed, and all of the performance benefits that we highlighted earlier. Another feature I'm really excited about is we launched Cluster Insights very recently. So this Cluster Insights feature, when you're managing a cluster, it monitors the cluster. It can give you insights into how nodes are performing, how shards are performing, give you recommendations for better tuning and optimizing your cluster, queries, hot shards. And all this just makes it much easier for you to make sure your cluster is operating at peak performance with detailed recommendations and insights. This is now available for any cluster running 217 or greater. You'll see a Cluster Insights link that takes you to the OpenSearch UI where this panel will show up automatically. A few other things I wanted to call out. The OpenSearch optimized instances, I mentioned those before. These are high indexing, high throughput instances that are backed by S3. We launched the OR1 last year. This year we launched our 2nd generation with the OR2, and we also launched our first M series of the OpenSearch optimized, the OM2. The OR2 has a 70% improvement in indexing throughput over an R7G. The OM2 has a 66 improvement over an M7G, and we'll continue to see improvements on those generations. So definitely check those out if you have not already and you have got high indexing workloads. We also added a derived source feature. What this does is it can cut your storage in your cluster by up to 40%. So OpenSearch traditionally keeps source, which is the JSON data, around. It needed that JSON data in case whenever they needed to do segment merges, shard reindexing, other sort of cluster operations. With this, we drop that. We actually don't use that JSON data for any of those operations anymore. We actually perform those operations based off of the pre-indexed data or the derived source. This not only means I don't have to waste 40% of my cluster on that source data anymore, it also is much faster, a 20% improvement in the indexing and merges because the data is already pre-indexed. So I don't have to index that data again to do those operations. So definitely just check that box, turn that on. It'll save you quite a bit of expense. I also wanted to call out the custom plugins. feature we launched last year. We added scripting plugins. If you have custom plugins, you can now run them on the service. And we're continuing to expand the capabilities of the classes we support there. So love to get your feedback on those features. I'm running pretty close on time, so I'll go quickly. On the Amazon OpenSearch serverless, which is the easiest way to get started with OpenSearch. With a serverless, I just create a collection. I don't have to worry about shards. I don't have to worry about sizing. So it's by far the easiest way. We're continuing to expand and mature the serverless product. We now support up to 100 terabytes in a single collection for time series data. We've expanded regions out to 22 regions. We added some key features like being able to audit data plane calls in CloudTrail and snapshot restore. And we're going to continue to invest in the serverless platform. Very excited about where that's going. So to wrap up, if you want to learn more, there's a link to our skills for more deeper learning on this topic and lots of OpenSearch topics. Also, we're at our booth. There's a booth in D23 in the AWS Village. There's actually also an OpenSearch project booth down there in the expo. Come down, say hi. We'd love to learn more about what you guys are doing, any questions that you have. And last but not least, I really thank everybody for coming. And if you could, please fill out that survey. That data is really valuable for us. We're want to make sure that we learn the good, the bad, and are delivering the best possible content for you guys here. So please take the time to fill out the survey if you could. And with that, I appreciate everybody sticking around for the hour, and really excited to talk about OpenSearch and see what you guys do with it.